In this video, we're going to talk about graphing reciprocal functions, and in this video, we're going to focus on linear functions only, and I'm going to do a separate video on quadratic functions. So let's say, folks, you are given the function f of x equals 2x minus 1, and you are asked to graph the reciprocal function. Let's call that r of x. So that would be 1 over 2x minus 1. So this video is going to be about how to graph this reciprocal function using the elements of the original linear function. Now, folks, before we talk about those methods, let's remind ourselves that we know how to graph this reciprocal function. We don't need the elements of the linear function to do that. So let's just do a quick review how to graph this rational function. Okay, first thing we notice is that this is bottom heavy. When a rational function is bottom heavy, it's going to have a horizontal asymptote at y equals 0. The next thing we know is when you look at where this function will cross the x-axis, the so-called zeros, there are none. Because the only way for a rational function to be 0 is if the numerator is 0. We have a constant up here, so there's no way that this rational function will ever be crossing the x-axis. This y value will never be 0. Now let's look for vertical asymptotes. Well, the vertical asymptotes are where the denominator equals 0. So let's set 2x minus 1 equal to 0 and solve for x, and we see that there is a vertical asymptote at x equals 1/2. Next, we notice that this factor below is to the first power. Excuse me. That means when the graph approaches this vertical asymptote from the left and the right, the graph is going to be going in opposite directions. What do I mean by that? Well, let's say quickly that this is our vertical asymptote for this graph, and it's going to be at x equals 1/2. Well, we know because this is an odd number, it's an odd multiplicity, that as the graph approaches the vertical asymptote from the left, it's going to head towards positive infinity, and from the right, it's going to head towards negative infinity, or vice versa. What you are not going to get in this particular scenario, because that's an odd multiplicity, you're not going to get them going in the same direction. Okay, let's keep going with our analysis. So I'm going to put a little opposite here to indicate what we just discussed. Okay, the next thing is, what is the y-intercept? So to get the y-intercept, we're going to set x equal to 0. In essence, we're going to put our thumb over any term that has an x in it. We're going to get 1 over negative 1, which means this is going to be our y-intercept. Finally, I want to do what I call a sign analysis. And when you do a sign analysis, you put down all the critical points on a number line. The critical points are going to be the zeros and the vertical asymptotes. Well, we have no zeros, so the only point on the sign analysis number line is going to be 1/2. We're now going to separate this into two zones, and we're going to analyze the sign of this whole function in zone 1 and zone 2. Okay, let's look at zone 1 and let's pick a test point. 0 is always easy. If we plug 0 in here, we're going to get 1 over negative 1, which is a negative. In zone 2, let's use 10. If we plug 10 in here, we're going to get 20 minus 1, or 19, in the denominator, which is going to be positive. So we know our graph in zone 1 is going to be negative, and in zone 2 is going to be positive. Let's now, folks, put all of this together. Let me make some room, and we'll do a quick sketch to show you what our final answer is going to look like. But we are going to use a different method. As I alluded to at the outset, we're going to be analyzing the original linear graph and graphing this reciprocal function. But here's the standard way that we learned how to do it. Okay, here's our xy axis. We're going to put in our horizontal asymptote at y equals 0. Recall, that's because the function was bottom heavy. We're going to put in our y-intercept at 0, -1. We are going to put a vertical asymptote at x equals 1/2. Okay. Next, we're going to realize that there are no zeros, so we are not going to be crossing the x-axis, which makes sense because we have the horizontal asymptote here. Now, the next thing we're going to do is we're going to remember that our sign analysis says that this zone is going to be negative and this zone it's going to be positive. So let's do zone 1 first. If this is negative, that means our graph has to be below the x-axis. So we're going to hug the horizontal asymptote, come through our y-intercept, and then accommodate the vertical asymptote. On this side, recall this has to be opposite because that is a multiplicity that's odd. So we know on this side of the vertical asymptote, it's going to do this, and the entire graph is going to stay positive. Folks, this is the graph of the reciprocal function. Now, we're going to get the same graph, but we're going to do it by analyzing the original linear function. And that is the crux of this video. Folks, let's now analyze the linear function graph, look at some of this information, and using the results of the information, create a graph for the reciprocal. First thing we're going to do is go to the original graph, f of x, and look at the zeros. That means where does this graph equal 0? Where does the original graph cross the x-axis? And that is going to be when 2x minus 1 equals 0. So let's go ahead and do that algebra. And we find that 2x minus 1 will equal 0 when x equals 1/2. So this point right there is 1/2. Folks, I apologize. This is not to scale. I'm doing my best to fit everything on one screen. Okay, now, wherever the original graph is 0, the reciprocal is going to be 1/0. So the reciprocal is going to be 1/0 when x equals 1/2. That means there is going to be a vertical asymptote on this reciprocal function at x equals 1/2. So let's go ahead and put that vertical asymptote x equals 1/2 on the reciprocal function. Okay, the next thing we're going to do is we're going to look at the behavior of the original graph as the graph approaches the zeros. Okay, so here's our 0. We're first going to approach from the left. All right, so let's look at what our y value would be down here. So we're going to say this y value down here, right here is, let's call it -100. As we move towards this 0, where x equals 1/2, the y value of the original function is still negative, but it's dropping down, say, to -10. Then -1. Then -1/10. Then -1/100th. Then -1/10,000, a huge number. All right? So as we approach this 0 from the left, the original graph is approaching -1/10,000. That's just below 0. So now what we're going to do here for the reciprocal is, as this reciprocal graph approaches the x equals 1/2 value from the left, instead of 1/10,000, this is going to switch to -10,000/1, which is a huge negative number. That means as our reciprocal graph approaches this value of x equals 1/2, the reciprocal graph is going to approach negative infinity. So we're going to mark that with that line right there. Okay, now folks, let's look at the behavior of the original graph as we approach the 0 from the right. Okay, so up here we're going to have a huge positive number. Let's say positive 10,000. This is going to be positive 100, positive 10. Again, I'm talking about the y value of the original function as we approach where the graph equals 0. So eventually we're going to get into fractions. Here it's going to be positive 1/10. Here, very, very close to 0, we're going to be at positive 1 over a huge number, 10,000. So as we approach x equals 1/2 from the right on the original graph, we're approaching 1 over 10,000 positive. Therefore, when we approach our reciprocal graph from the right, as we approach x equals 1/2 from the right, we're going to have the reciprocal of 1 over positive 10,000. That's going to be positive 10,000, which is a huge positive number, namely positive infinity. So we know our graph is going to be approaching positive infinity as it approaches x equals 1/2 from the right. Okay, let's clean up a little bit and then look at our next on the list. And we see that we're going to look at the end behavior of the original graph. Okay. So end behavior means what is the graph doing as x is approaching negative infinity and positive infinity. And we know from the work we did on the last side that there's a horizontal asymptote, but we can't use that here. That would be cheating. We have to use the original graph to create the reciprocal. Okay, so let's look at the end behavior of the original graph. So look what's happening. End behavior means what is happening as x approaches negative infinity to the graph, to the y value of the graph, and what is happening as the x values approach positive infinity. That is what end behavior is. So let's look now at the y values as the graph approaches x equals negative infinity. So we see the y values are dropping. All right, so where are the y values headed? Here we're at negative 10, negative 100, negative 1,000. They're heading towards negative infinity. All right, now, if the original function as x heads towards negative infinity is headed towards a y value of negative infinity, then our reciprocal function is heading towards 1 over negative infinity. 1 over negative infinity, we could think of 1 over negative 10,000 or 100,000, whatever that is. So as our graph heads towards negative 1 over 100,000. All right, if we look at a number line here, and this is 0, and we're at negative 100,000, it's getting very, very close to 0 from the negative side. Here's negative 1/10. Here's negative 100. Here's negative 1 over 1,000,000. You're heading towards 0 from the negative side on your reciprocal graph. That means this graph, our reciprocal graph, as x heads towards negative infinity, the y value of our graph is going to head towards 0 from the negative side. That's indicated by that arrow right there. Okay, now we're going to do end behavior on our original graph as x approaches positive infinity. You can see on the original graph as x approaches positive infinity, our original graph is heading towards a huge positive number or positive infinity. So instead of positive infinity, let's use the number positive 1,000,000. Okay, now we're going to go to the reciprocal graph. right? We're going to keep that original number line. And instead of, whereas the original goes towards 1 million, positive 1 million, the reciprocal graph is going to head towards positive 1 over 1 million. All right, so it's going to be at positive 1 over 10, positive 100th, positive 1 millionth. So when you're heading towards positive 1 over a million, you're heading towards 0 from the positive side. That is what our graph is going to do. So I'm going to indicate that by an arrow heading towards 0, the y value heading towards 0, but from the positive side. Okay, the next thing, folks, we're going to look at something called invariant behavior. And what that means is that when you have an original graph that equals 1, okay, so where does this graph equal 1? Again, everything is way off scale. But that's negative 1. So I'm going to say that our original graph is equal to positive 1 right at that point. Right there. Now, folks, when you have an original graph that equals positive 1 and you do a reciprocal, what do you get? The answer is positive 1. So that point does not change when you go from the original function, where this function has a y value of 1, it's going to be the same location on this graph. So I'm going to say that this red point, all right, whatever x equals here, let's say this is x equals 6. At x equals 6, our reciprocal point is going to be at y equals 1. Because 1 over 1 reciprocal is still 1. Now, folks, the same is true with negative 1. So I'm going to say our graph equals negative 1 right there at the y-intercept. There it is. No, hold it. My mistake. Where does this graph equal negative 1? So we're going to set 2x minus 1 equal to negative 1. 2x equals 0. So it's going to be where x equals 0. All right, I was right the originally. Okay, so our original graph equals negative 1 right there. That means our reciprocal graph is also going to equal negative 1 right about there. Because the reciprocal of negative 1 over 1 is still negative 1. Invariant points, where the original graph equals 1 and negative 1, whatever x values they are, they're going to be on the reciprocal graph. Okay, the next thing we're going to do is we're going to go ahead and we're going to sketch our graph at this point. And then we're going to cover the last two on the list. Okay, here we go. We have a graph, the reciprocal graph, that comes, it approaches 0 as you're heading towards negative infinity. It's going to come through that invariant point, and then it's going to approach negative infinity as it approaches the vertical asymptote. Up here, as the graph approaches the 0 from the right, it's going to approach positive infinity. And as it the end behavior is going to have it coming towards 0 as x approaches positive infinity. So here is our graph. Sorry, this is kind of funky here. Let's see if I can make that just a little neater. Thank you for your patience. Okay, so let's just say that invariant point was up here instead of down here. Folks, this is our graph of the reciprocal function, and it matches what we had previously when we did the graph. No? Okay, I can't remember where the other slide is. Where we did the graph using conventional techniques. Now, let's look at the last two. increasing or decreasing. Our original graph is always increasing. Sometimes it's tricky to figure out when a graph is increasing or decreasing. So this is what you do. You go left to right. All right. You ask yourself, what's happening to the graph as the x values are moving left to right? All right. So as your mouse is moving this way, okay, we're going to get on the graph. The x values are going this way, but we've got to stay on the graph. All right. What are the y values doing as we're heading to the right on the x-axis? They're increasing. So this original graph is always increasing. Always increasing. Let's look at our reciprocal function. All right, we're going to move from left to right, and we're going to look at what our y values are doing. Okay, here we are. We're on the graph. What are our y values doing as we move left to right? They're decreasing in this segment. Then we're going to jump back on the graph up here. We're going to continue to move from left to right. What are the y values doing? They're decreasing. So our reciprocal graph is always decreasing. And that makes sense because they're reciprocal graphs. Okay, finally, positive or negative, i.e., are you above or below the axis, x-axis? Okay, keep in mind, if you have a positive number, positive 3 over 1, and you do the reciprocal, it's going to stay positive. Same with a negative number. If you have negative 2 and you change it to negative 1 over 2, it's negative. So look at our original graph. All right, here's x equals 1/2. That was the 0. Everything to the left of x equals 1/2, look at the y value of this graph. It's negative. Look at our reciprocal graph. Here's our vertical asymptote at 1/2. Everything to the left of this x equals 1/2 is negative. That is accurate. Okay, same thing positive. Look at our original graph. Where x is to the right of x equals 1/2, our graph is above the y-axis, meaning this graph is positive in this location. Look at our reciprocal graph. If we go to the right of x equals 1/2, our graph stays above the x-axis. Folks, in summary, yes, you can graph this using standard techniques, but your teacher is going to want you to go from this graph to the reciprocal graph using these analyses. You have to evaluate the original graph as you approach the 0, where y equals 0, that's x equals 1/2, from the left and from the right. And we're going to translate that information to the reciprocal graph. We're going to look at the end behavior of the original graph, and we're going to look at the reciprocal. That's going to be the end behavior. So look, on the original graph, as we go to the left, end behavior, this is getting big, 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 big negative. It becomes small, small, small negative, which means it's approaching 0. The end behavior on the original graph, big, big, big positive. You go to the reciprocal, it's going to be small, 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 small positive, which means it's going to approach 0 from the positive side.